Testing, testing. Aha! There we go. All right, here, let's move things around a little bit. Testing, testing. Aha! There we go. I can hear myself. Should mute. All right, my own stream. That's embarrassing. All right. Move things around a little. Let's see here. Close that. And find chat. Okay. Hello. So, hello everyone. I don't know if anyone's watching. I can see one person is watching, but it might just be me. I can never tell on these things. So, let's see if there's a better way to do this. Let's do a little social media update in this wild world of ours. Tiny moving light. If there is someone watching, you can find me at Jeffers Glass, Jeffers Glass on Twitter. All right, let's update this, and we'll update the other. Starting a slightly different. Let's see. What are you seeing? You're seeing my face, yeah. So I'm streaming from my office this time, as opposed to from the front room. So the monitor setup is a little strange. So if I'm looking off wistfully into the middle distance, you'll know it's just because of my operational monitor is up there. Update the Facebook because it's 2018 and that's what you do. Alrighty. Let's see here. What I really need is a way to keep. I want to be able to see OBS and my stream dashboard and chat all at once, and I don't have enough monitor space to do that. What I would sometimes do is I could use something like a Triple Head to Go, which is a Matrox product, which allows you to split one video output into two, which is kind of cool. So it basically presents itself to your computer as, your computer sees one HDMI output, and the display presents itself as like a single, like instead of 1920 by 1080, it might be 1080 by 3840. So it thinks it's one ultra wide display, but it's actually two separate of your monitors, which is kind of nifty. All right. I don't know if I hide the chat, do I lose chat on stream? I don't really know. Well, I've got something like a monitor setup going, so we'll see if we'll see how well it holds up. I can see chat, I can see the stream health. That's all I really care about. And hopefully, let's just try the link I've been using. I think will take me to the right place. But let me just double check. Yeah, cool, looks good. All right, let's give everyone just a couple more minutes and we'll see if anyone shows up. The gist of what I'm gonna be working on today, which, oh, hello. Oh, my chat window has become Goliath. That's not okay. Let's shrink that a little bit here so I can actually see when people talk. There we go. So, let me bring the dashboard back up. All right, so the gist of what we're working on today is going to be the mini moving light project. Although, while we're waiting for folks, why don't I show off? So the last time I streamed, we built a box for the mini QRP amplifier. Let's see if I can get Fusion to load here. We'll just buffer for a little bit. Buffering, buffering, buffering. Buffering, buffering, buffering. Buffering, buffering. There we go. All right, so this is the project we built last time, which is just this 3D printed case for a miniature 50-watt HF amplifier project that I've been working on. So let me close the window there. So this box has 3 parts, namely the PCB, which I designed in Eagle, in Autodesk Eagle project, and then imported in. So all those footprints match what the footprints are on the actual PCB. We have this box bottom here, essentially, and then we built a top for it as well. And after the stream, I went ahead and did some labeling on the top and sort of inlaid this text, which I think turned out quite well, actually. So, and then obviously there were some things that we left not done from that stream, like these power poles here, and that power pole model was by Chris Wick, who's a props master and who is delightful, who shot that my way. So obviously there's no strain relief there for that, so we'll need to think about something better for that. But for the time being, sort of this is the project. So let me take 2 seconds and get my my iPhone capture set up here, which is what I'm using as my sort of remote cam. And let me see if I can get phone. Oh, that's right. I have to have VLC. So what I'm using to stream a phone image to OBS is this app that's just called IP Cam, and then for whatever reason I have to have VLC open to be able to create a VLC source that it thinks is the iPhone, which is very strange. And I'm not quite remembering how to make this work. Here, I'll show you what I'm dealing with here. So on the right hand side of the screen here is OBS, which is my streaming software, so we got a kind of an infinite recursion thing going there, and over here is VLC. So what I'm trying to do is get but let's see, why is this not behaving as I want it to? VLC, because I don't think that I should necessarily have to have, oh, you know what it is? I think I have to recreate this VLC source. So we'll delete that. Delete that. All right, so this is going to be a VLC video source, and playlist is going to add a path, and that's going to be the IP address of my iPhone, 192.168.1.132. Okay. Let's see now. 192.168.1.132. Oh, and I think I have to do /live or something. Not video capture device. You're seeing all of the behind the scenes VLC video source. /live. Yeah. Nah. Clearly should have tested that out before I got the thing started. Well, I can show you on. Oh, there it is. That's my live phone source, although it's not updating live. Ooh. It's got a lot of lag, is what it's got. That's unfortunate. Why does it have so much lag? I feel like last time we did better. In any case, I'm going to show you something that's pretty static, so I think we will we'll get away with it. So I can probably position this a little bit better. So orientation-wise, this is also not ideal. So you guys are just like, we're just gonna have a whole fun time together. Whoop. We'll just scale this, and then we'll transition. Yeah, great. All right, so this is the box as it printed. So you can see on top here, I have all my nice lettering. I guess it would be probably this way up is better. So I have my call sign, I have amplifier, I have all the labeling worked out pretty well. I did this at the bottom layer, so it's pretty smooth. The holes didn't turn out great. I was printing a little bit faster than I should have because I was in a hurry. And then this is the box. So you can see we built this box that has this cutout in the bottom here, which was to accommodate the FETs going through to come down and touch a heatsink. It's got the 3 little standoffs to mount the PCB to, and then it's got these 4 corner posts which hold up the top. And then cutouts on the sides for all the components. So it came out all right. The bottom's kind of a mess. It had some pretty serious lifting, again, because I set this up in a hurry to try and get one printed off, forgetting that where my printer is now, which is different from where it was several weeks ago, it has some airflow currents around it that it doesn't usually, so the lifting is pretty bad. So I'll need to sort of build now that it's in this location, I'll need to do some better airflow control around it. But let's go back to Fusion. I just feel like I'm looking up and above everyone all the time, which is it's just a little weird. I've got my control monitor up here, and I've got Fusion down here with the camera, so I can be looking toward it most of the time. Excellent. Let's see. I just want to make sure that this actually shared. Let's make sure this is edit post. Let's make sure this is the same thing. Looks like it is. Yeah, alright, well, never mind then. Discard, leave, yes. Alright, well, if there's one person out there, then this stream is worth it. So, the project we're going to be working on today is... Let's see, I think it's this project. Make sure you're looking at the right thing. Yeah, huh. I think that's right. When I was first using Fusion, I wasn't very good at doing like the file management part of it. So some of my file structure is a little bit messed up, which is a bit of a shame. Yeah, this is the one. Alrighty. Here, let me take this away from you for just a moment and clean up one thing. All right. Let's see. It's a photo or video. Split. All right. Very good. Okay. All right. Sorry, didn't mean to take that away from you. Okay. All right. So there we go. Let's check OBS. It's the last time I streamed, I was so bad about checking to make sure that we actually had the correct source visible on the screen. I kept showing like my camera when I meant to be showing the screen itself, but I think we'll get through just fine. I'm also going to just lighten up chat a little bit there. All right, so this is the mini moving light project as it currently exists. So this moving light, let me show you the actual physical object, and then I can get to showing it to you in CAD. So let's see if that's still live. Yeah, there we go. Okay, so so this is the actual miniature moving light, which you can see for scale is about 4 inches tall. It has this base which hides a 9G microservo, which you can see sort of poking through the bottom there. It has one arm on one side, and then this body is in 2 parts, and that hides an additional servo on the inside and a little RGB LED chip. So that's the gist of the project as it currently exists. And the rest of this is a demo board that I put together to be able to sort of work with this a little bit more easily. Some of this is no longer going to be necessary after the next set of revisions, but essentially... Ooh, I'm so sorry. All right, we're back. Essentially, what you've got here is an Arduino Pro Mini with the FTDI adapter hanging off the end. This is a 5-volt regulator because I figured running the LEDs at about 5 volts was just about right. Except it's a variable regulator. Actually, I forget what I had it set to. It can't be 5 volts. We'd be toasting things. I have down here, I believe, a ULN 2003 dip chip, which is 7 NPN transistors with their emitters tied together. So it's really useful if you're driving a bunch of relatively high power loads in parallel. And then I have some low value resistors down in there between that and this header strip. And then this ribbon cable goes out, goes in the butt of the moving light, and then up to that LED. And I'm actually using, so this is, I believe, 7 conductors of ribbon cable. So that's for 4 channels of LED, and then I have the common anode tied through 3 of these because it's like 26 gauge ribbon cable, and I figured the extra copper in there couldn't hurt. And then over here, I've got, this is a 5-volt regulator. So the 5-volt regulator is for driving 5 volt to power the Arduino from, and then this variable regulator is for powering the LEDs. And then I have 2 push buttons, 2 utility push buttons here, just to, if I want to, have some function on the Arduino that is, variable if I'm going to demo this thing. So let's turn this on. There we go. Excellent. So that's the gist of it. Let me turn it sideways here. I'm trying to lens flare too much. Get a little more light on it. So you can see, that's the gist of that little guy. I think with what's running up now, the buttons, change the movement pattern. So it's doing like a full searchlight mode. It's also, I have it hooked up to my variable bench power supply, which only goes up to 500 milliamps, and for some reason is current limiting pretty strongly right now. So in some of the faster movement modes, I'm actually browning out my power supply, so it's not able to go as fast as I want it to. But you get the idea. Kill that for now. So let me take you back over to Fusion. So interesting. It's a lot fewer people here than last time, and I'm hoping I've done the link correctly. People are actually able to find this, but I think so. I just shared the link from my YouTube page, so I assume it's going fine. Alrighty. So let's make sure again you're looking at the right thing. Yeah, so you're looking at Fusion. So what I propose to do this time, if we turn on all of the parts here, we can see all of the ways that this thing is built. Yeah, so this thing has essentially 1, 2, 3, 4, 5, 6, 7 primary components, right? So I have here, let's turn them all off, and I'll build this thing up one at a time. Maybe you can have a look at how it does. Let's see. Turn those 2 off, shell left, shell right, and there we go. So I've got my pan servo, which is this base servo here. That is covered by, so there's a component which is the base holder, which is just this 3D printed part, which is locks into that servo with a couple of screws, so it stays right there. That all gets covered by this base cover, which just fits snugly over that and has a little registration notch down there. And on top of this servo, we have the yoke, which is a one-sided yoke. Because, the traditional moving light would have a yoke going both ways. You'd see sort of support on both sides, which would be stronger, but for the weight that this thing is, it's really sort of unnecessary. And then I've got my tilt servo, which forms the center of the body of the light. And then I have, let's see, my shell? One side of my shell? Yeah, 2 sides of my shell. So you can see the left side of my shell is where the servo actually mounts to and provides the attachment points for that pan servo. And then the right side of that shell, if I take the other side away, is actually just cosmetic. so it's not actually there to provide any functionality other than to look pretty. I'm actually looking at this. I think this is not the most recent version of this design, because after I did this, I put some connection flanges in between these two halves. You can actually, if I take you back to the iPhone cam, you can see, hopefully see right on the top there, yeah, that little nubbin that goes across. So that's on the left-hand side of the device, and it fits into this little sliver of a slot on the right-hand side and helps hold those two together. So, and that I know was a late add. I think it was the last thing I can recall adding, but that is very odd. I wonder, let's see, moving light bits. I did restore that that recovery file right when I opened it. I wonder if that was a mistake. No, I don't think so. Well, all right. Well, that's lost to history. That's kind of exciting. How very strange. Alrighty. Well. So what I'm proposing to do this evening is to to begin the process of adding additional network capability to this device. So as I think I mentioned the last time I streamed, I've been doing a project over the summer. Oh, you're probably looking at the wrong thing. There we go. Where I did a little SACN-powered spot monitor for the folks down at Santa Fe Opera, which basically slurped SACN off the network and displayed the level of a single channel on a small display screen. So that was a good experience working with Arduino and SACN messages. So I thought I would bring some of that knowledge to this mini moving light project. So what I would love is to be able to plug this thing in to power and network and actually have a tiny moving light sitting on the network doing what I want it to do. So first things first, let's save this. And let us let's do a save as. So I want to preserve this design exactly as it currently exists. So this is going to be called Moving Light Bits. We will save this as Moving Light Intelligent, which will be quite good. Save. Oh, well, oh, good. I did not crash Fusion, which was very exciting. All right, so the pieces that I am going to use to intelligentify this moving light are a couple. And specifically, it's this. Here, let me take you over to the other camera again, and I can show you a little better. So this is just a little. So the other Arduino was a Pro Mini. This is a Pro Mini. This is a Micro, and it's just sitting on top of this little Ethernet shield. Now, the primary chip in this Ethernet shield, I think, is an ENJ4 something something something, which is a different Ethernet chip than I was using in the SACN monitor project, which will make this just a little bit more complicated. But what I'm hoping to do, and from my initial research I think I can do, it should be fairly straightforward to translate that Ethernet library into something that can make use of this specific Ethernet hardware. So I'm sort of going to go forward assuming that I can make that true. So the ideal hardware stack up, just for the sake of size for this project, would be the Arduino Micro, the what is it? I'll tell you, I'm going to say this like 1,000 times over the course of this presentation. So, oops, let me take you back to Fusion. What is it? Arduino Micro Wi-Fi. is the name of this Wi-Fi chip? No. No, not Wi-Fi, sorry, Ethernet. What does the Ethernet shield use? Here we go. Oh, interesting. So Arduino has one that is, Adafruit has one that is Feather compatible. They have their Feather line of products. That is WIZ5500, which is the same chipset, but they're very expensive, like all things Adafruit tend to be. Not that they're not worth it, but the primary value of a stack up like this is that the whole thing costs about $3.50. So if I get it working on something at sort of this level of expense, then it would be very economical to make lots and lots of these, which would be a lot of fun. I am just going to try to figure out what the name of this chip is. Arduino Ethernet ENC28J60 is what I'm thinking of. Yeah, that's exactly right. All right. All right, so I've got the ENC28J60 shield. I have the Arduino Micro, and I think what I will end up doing is on the bottom side of this, I will make my own PCB, which I might do with headers. I probably should do with headers, or could just do through hole to these extra long headers and solder the PCB in. That would sort of save on depth, but I think just for like modularity, it might be nice to be able to disconnect these. So that bottom PCB would have connections for the LEDs themselves, for the two servo motors, and probably some mounting holes on it. So that's actually going to affect what I'm working on tonight. And then it would probably also have a DC input jack, because on this guy here, I don't know why I'm using this camera. Let me take you back to the better camera. So on this guy, I've got USB in for the Arduino programming and power, and then I've got the RJ45 jack with the 8P8C jack. Sorry, Kenneth. And what I would like is to have this sort of be the user-facing end. Where's the camera? Nope. There we go. User-facing end. User-facing end here. Then we have a PCB that sits here, and we'd have a DC input jack there. So we'd have DC power and Ethernet. Or if we were had a PoE-enabled switch, we could use one of those nice PoE splitters, do Ethernet in here and power in here, and only have one cable running to it. Now Travis down at Santa Fe Opera tried to make use of that for the SACM project, and we had some voltage drop issues. It doesn't seem like the ones that he bought, which are ones from Adafruit, really could do 12 volts at 1 amp like they claim to, which is a bit of a shame, but sort of more study required on that one. Give me one moment, y'all. So while I continue in social media land, let me describe to you what I intend to do. So right now this mini moving light has to be sort of hardwired into a test rig like I showed you a moment ago in order to function. And what I would like to do is sort of expand in this area here the 3D printed base so that I could fit a stack up of Arduino and Network Shield and PCB such that I could have all that control sitting next to this servo in the base, and we could sort of have a self-contained moving light. So what I'm going to do first, I think, is make a really rough, accurate but rough 3D model of this with a PCB with a sort of additional PCB attached to it, and then I am going to hopefully export that PCB area into Eagle and do the PCB design, and then bring it back in and finish the mechanical design after that PCB is done. And I'll have to make some choices along the way about mounting points and size, and how this is all going to attach. So first things first, I'm going to preserve most of the work I did earlier, because this design turned out really nicely, and it took probably a dozen iterations of printing all these parts until it really worked well. The longest one was printing the interface between this basically spur gear at the top of the servo and the plastic of the moving light arm, because it's just a friction fit that you put a screw into, and so I did a bunch of different test fits to make sure that worked out right, and was as secure as I wanted it to be, while still being able to get that on there. So I'm going to use this as the basis for my design. while sort of making improvements around it. But first things first, let's make a new component, and we will call this Arduino plus Ethernet. Can I have a plus in there? Yeah, I can. That's nice. Okay, and actually what I should do is delete that component. I should, since this is its own object, and I don't really need to base any of its dimensions off of the existing dimensions in this project, I can just do this as a separate design and then import it in, which is really what I should do. So I'm actually going to make two components here. This is going to be Arduino Micro and a new component for Ethernet. Alrighty. Okay, so let's start with the Arduino Micro, and we'll just, again, make sure you're looking at the right thing. Yeah, for sure. You know what, let's do, so you're in this one, yeah? I'm gonna see if I can, because I'm gonna be back and forth between the fusion and looking at the physical object, I'm gonna do a quick setup in OBS here, and then I can show you both of those things on screen at the same time, which I think will be quite helpful. Display capture, no. Alright, sorry. Video source, yes. Alright. I'm going to add a VLC video source. It's going to be to a URL, http://192.168.1.32/live. Alrighty. Interesting. It doesn't seem to be wanting to show up. But if I see. So maybe I need to actually have the display sending before it will allow me to see it. Now you can't see anything. Well, that's no good. Now why would that be? 192.168.1.132/live. I don't know why that is. Well, screw that then. But you can still see it if I come over here. Yeah? Yeah. That's super strange. Alright, well, I'm going to leave you on Fusion because I think the drafting part of this is going to be more interesting than the measuring part of this. Let's transition back. Alright, so in my Arduino component, I'm going to first start with the top part of this board here. So I'm going to make a sketch, my ground plane there, do a rectangle, there we go, we'll get some dimensions for that rectangle. That PCB is going to be 42.3 by 16.6. So it's going to be 42.3 by 16.6. And I bet it's 1.6 millimeters tall. Oops, come on, 0. It is 1.25 millimeters tall. All right. So I'm going to extrude this face one direction, 1.3 millimeters. New body. All right. So that's the bare bones of my Arduino there. And now I have, let's see here. So it's got this header section. So I think what I'm going to do is just represent just the header pins as an additional extrude of 2.7 millimeters down each side, and each one should be about 0.1. That makes sense because they're 0.1 inch headers, so they're about 2.5 millimeters across. And I'm just going to go. This is really just to be sort of a quick and dirty model of of this so I can do some mechanical design with it. So I'm not even going to worry about where on this side the header pins actually start. I'm just going to mirror, select a mirror line. Great. Actually, this one should not be. Great. All right, so that's those, and then I'm going to extrude those out, distance of 2.7 millimeters. Great, so that represents the little extents of the header pins there, and I should probably do something to represent this USB as well. Great, just making sure you're actually looking at the right thing. So that USB is 7.5 by 9 millimeters. Let's see, from the body is 8 millimeters. So we will do a sketch on this top layer. Again, we'll do center there. Not extension line, so we'll do a line there. We will mirror this over our center line. Its total dimension is 9.2 millimeters. This point is 1.2 millimeters from the edge. We will do lines down here to make it a full rectangle, and those lines we said had a length of 7.5 millimeters. Great, so there's that, and then this and this, we're going to extrude upward for a length of, call it 4 millimeters. Where's my mouse? There we go. Okay, so that's going to represent the USB nubbin on the end of my Arduino there. Let's see here. All right. So, okay, so that's gonna do it for my representation of my Arduino. I think doesn't need to be fancier than that. So we'll come over here to the Ethernet portion. And I'm going to base this off of the end of my Arduino. So those female headers are, oops, turn the calipers on. Those are 8.4 millimeters tall. So, come on, let's go to the bottom here. We'll do a new sketch. We'll do a new sketch on this face. Do I need? Oh yeah, I'm just gonna project the upper geometry down. I'm gonna extrude the same rectangle, so I'm gonna rectangle that, and I'm gonna extrude this for a distance of 8.4 millimeters. So those will be my female headers, and then I'm going to do a sketch on the bottom face of that. And the sort of USB end of the PCB exactly aligns with the end of the Arduino, and they're the same width. So I'm going to start like so. And so really the only dimension I need to define is how much space is between those headers and the end of the PCB here. And so I can measure that. And that is going to be, let me re-zero this. Yeah, there we go. So that from the headers to the end of the PCB is just about 21.8 millimeters. So I can do that. So we'll do dimension from here to the end of 21.8. Great. We'll stop sketch. We'll extrude this downward to become our other PCB, and that is 2.1 millimeters thick. So we'll do an extrude of 2.1. Oops, that's not quite right. Let's go back into our extrude. I want to extrude this as well. Great. So that is our PCB and female headers, and then I'm going to represent the RJ45 jack on that as well. So this RJ45 jack is a total of 16 millimeters wide, and it begins, call it 16.8 millimeters back into the PCB. All right, so we'll do a sketch on this face. We will do a rectangle. We said it starts 16.8 millimeters back. We said this total width is 16 millimeters. We're going to make sure it is centered. So I think if I do this, if I select that line and I do midpoint of this line, yeah, there we go. So that's now nice and centered. And then the total length of that connector, zero that again, is 21.1 millimeters. So that's the overhang. So we can stop sketch. And the total height is 13.4 millimeters. So we will extrude both of those upward for a distance of 13.4 millimeters, and that's our RG45. I guess the only other thing I might want to represent is the pins coming off the bottom of that network shield. But I think we can sort of let that go for now. The only thing I'm going to do is save. That's Arduino Micro and Ethernet. Give it a second to save. And I'm going to add some physical materials to this guy. So I think what I'm going to do is actually this last extrude where I made the Ethernet connector. I'm going to make that a new body. And I'm going to go back and do the same for this extrude where I made that USB connector. Make that a new body. Because when I move this around, I'm going to do it as a whole component. So I'm not going to have to worry about those things separating from each other. But making them a different body just allows me to make them different materials, which will be sort of make this thing look a little bit nicer. So I can make that red. Let's select the whole component here so we can see what we're doing. We'll do physical material. And the intended purpose of these is so you can like simulate your materials properties, but I'm just going to do it to make things pretty. All right, so that's my really rough and tumble representation of my Arduino and Ethernet. So it's dimensionally accurate in its outline. It's not super duper pretty, but it doesn't need to be. Like I can always go back and clean this up later. I don't think there are any other real salient dimensions. I mean, there are the nubbins here that are the top sides of the header pins, but I don't think those are really necessary to represent in this sketch. So let's save that one more time. And let's import that. So I should be able to, I think, insert into current design. Do. Stream resumed. Something very strange is happening. Let me just take a little side quest here and see if the stream is still showing up. Kind of seems like it's not. Kind of seems like not a lot going on. Why is that? All right, well, a brief diversion. Like this went away a long time ago, didn't it? That's a shame. Well, I have not great ping to the outside world, huh? Hard to tell if anything is actually happening. Oh, well, that's a good sign. All right. Well, we'll just carry on, and we'll see how we do. Because if nothing else, this is just something I've been meaning to do for a while. All right, so I've inserted my Arduino and Ethernet into the current project. Now I need to do at least a rough alignment on them. 'Cause I've been imagining that, oops, yeah, this comes in. We mount them something like this so that the Arduino stack up sits adjacent to the moving light itself. Although I think I really want it to be like this, which is going to be pretty non-standard, but I think is going to allow me more room over here to do the later PCB work that I want to do. So let's, what's this actually sticking out? So it's the USBs in the back. And the Arduino, oh, and of course, in three-dimensional space, we're totally in the wrong. Let's home everything. Go back to where we started. Woo, we're way out there. Okay, what has happened here? Let's get ourselves closer in three-dimensional space. All right, let's do that, and we'll do that, and we'll do that. Okay, so we should be close in 3D again. Yeah, okay, that's much better. We're at least closer. So from the front here, stack that up sort of there, and then from the side, yeah, so this is the thing about making this modification is that it is going to increase the size of the space by a significant amount, but I don't think there's really any way to avoid that, and I think for the amount of additional functionality that we're going to gain, it's totally worth it. Okay, so we'll leave that there for now. And we'll select that as a component, if it will let me. It's struggling a bit. I'm going to, no, I should leave that there. I should make a new component for our new base. Call it the big base. I can hear my partner Mary cheering in the background because the Bears must have scored. Alrighty, let's see. Okay, so really I need to just expand this base so that it accommodates the new Ethernet hardware. So I think what I will do is make a new cover. So I'm going to leave this mounting plate. How do I want to do this? I really want to, what I probably should do is duplicate this mounting plate, make a version of it that encompasses this entirety, and then make a new version of a top cover. But how is a top cover going to get in there? And ultimately, how is this thing going to be mounted? Let's make this back to 3D so we can actually see what we're thinking about. So my ultimate plan is that there's a PCB on the bottom side of this that has mounting holes on it so that I could mount it to this device. Maybe instead what I want to do is rethink the positioning of this. Oh, I see. Aha. This is why I didn't have my mounting tabs earlier, is because I wasn't all the way forward in the timeline. Aha. Well, great. So there's those mounting tabs we were talking about a while ago. And if you're just joining us, hello. Working on our mini moving light project here, working on this Arduino simulation block that I built just a moment ago, working on integrating that into the 3D printed design of the mini moving light. So I was just trying to think about the placement of this thing, which right now is representing this thing with the Arduino on top and the ENC 60J28, I think we decided it was called, the network shield sitting on the bottom, and how we were going to have this in relation to our servo here, which forms the basis of the moving light. So I had been picturing it like this the whole time, but I sort of wonder, let me go back to the, the point in the timeline where I added it, because I'm sort of thinking now that it might make more sense to rotate components, all of the above. Can I rotate assemblies? I can't. That's weird. Let's see. Well, that seems to have worked out okay. So what I'm sort of wondering is, what if that PCB has mounting holes on it and the whole situation is mounted like this? So I have the PCB that goes in first, gets mounted down, and then it has headers that allow me to insert these two devices on top. I think that's feasible. And then if I do that, so these are sliding in from the top, so it'd be something like this. And if we do this, I'll go back to this other thing we built earlier, and I'll build this in so we can sort of get this dimensionally right. So this is all sliding in from the top. So this has to be in the clear. So there has to be a slot on this base unit. Whatever this base sort of cup is that's holding everything has to have a slot in the top, and then it would have a cover that goes over it all. Now this could all happen before this arm goes in. So I could have a cover that comes down and slots over everything. That's really interesting. And then it could have the mounting holes that I want. Yeah, all right. I think that's the way to go. I think this is going to be fine. So back over here in our Arduino / Ethernet shield land, I'm going to make a third component, which I'm going to call my cape. It's not really a shield. I guess it'll be a shield. It'll be a shield. We'll call it the ML shield. And it's going to have headers on it as well. For the time being, so that what's a little bit strange about these Ethernet shields, you can see the Arduino pins and the Ethernet shield pins are quite a bit different in length. So I'm not quite sure what the story is there. Ooh, I can see someone is pinging me. Oh, it's once again my partner, Mary Hungerford, who is delightful. So I think the thing I'm going to have to do is either, when I get these, trim all those pins down on the Ethernet shield, which is a giant pain, or account for the additional length of the pins in the height of my headers. And I think that's what I'm going to do. So we said earlier that the height of these headers, which was the height of one of our extrudes on the Ethernet shield. Let's see here. Was it this extrude? No, it was the first one. It was this extrude. The height of this extrude was 8.4 millimeters. So the headers on this one are 8.4 millimeters, and the pins themselves on the Arduino are 6.4 millimeters. So there's an extra 2 millimeters of space in the bottom of these that's not occupied by pin. So if we assume that really is unused space, and these pins are, oops, gotta turn the thing on, Jeff. These pins are 9.2 millimeters, whereas these were, what? I've already forgotten. 6.2. So the extrusion for this next set of headers should be 3 millimeters longer. So these were 8.2, so the next one will be 11.2. I'm sorry, I could have kind of breezed through that, but I think it'll make sense when we see it visually. So we'll go back to our ML Shield image here. We're gonna make a new sketch on the bottom side here. We're gonna project some of our upper geometry here. I'll turn that shield off. We're gonna project because it's the same. It'll be the same header footprint from this Arduino above. Is it projection geometry? Can I project? Why is it not letting me project the lines of this model or the faces of this model? That's weird. All right, but that's all I really need. Okay, so we'll project that. And then we will extrude that down. We said 11.2 millimeters. Now, not all of that in reality is going to be header space. Some of that is just going to be free hanging pins, but that'll be okay. This will be a good enough representation. And then let's assume that our PCB material will probably be 1.6 mil FR4 because that's what's cheap from China. So let's do another sketch on this face. We'll do a rectangle, and we will extrude it by 1.6 millimeters. All right, so that is going to represent our shield that we're going to construct. And in fact, we'll try something cool here. So I'm going to make this a new body. And here, we'll change the materials just because we can. So let's do black for the headers. And this PCB, can I do a green? Is there a green option? How about ABS plastic? But let's duplicate it and change it. So I'm going to change its color to green. Apply. All right, so I'll make this green. So what I'm hoping later is that I can take this body and take it into Eagle as a PCB. Because the last time we did a stream, we imported an Eagle PCB into Fusion. And we used the existing PCB as a basis for a 3D printed design. What I'm hoping this time is that we can use a body that we've made in Fusion 360 as the basis for a PCB. That is supposed to be possible. I have never tried it. But maybe we'll find out tonight. All right, so that's saved. So I think, yeah, so now I've got this warning here. Component is out of date. So if I go in and I update it to get latest, it should slurp in that. Yeah, cool. So that's the new version of this guy. Let's go back to the end of our timeline. Yeah, okay, so now I would like to, here I can just move copy. Components. So if I rotate this around so it's vertical, so this is sort of what I was theorizing for our stack up. Boop. Over that base. Yeah. Which is not bad. So the idea here would be that bottom PCB that we have yet to build has our mounting holes on it. So the assembly in this case would take this bottom PCB, we would mount that to the board, then we'd plug in the Ethernet shield, we'd plug in the Arduino, and that would be all of the connections we need. And I think because this servo, as oriented, only has 300 and it only has 180 degrees of swing, there's no chance of it actually coming over here and hitting the protrusion that's going to be caused by this other hardware. So I think this is good. I'm just going to center this up a little. It feels a little weird to me to do, what I want to do is that, but given that this Ethernet jack is going to also define the overall size of my my box down here, as it were, I think this is more like what I want to do. Something like that. All right, let's capture that. And before I forget, let me move my timeline. Oops. Fusion's crashing. It's all very exciting. Okay, so there's that. So now I can start to build my box around this. So like I say, I think what I want to do is take this base holder and, here, let me move my timeline. Shoop, all the way to the end so we get all those nice features that I built last time. I want to take this and duplicate it. Let's save copy as, save as STL. Show hide. Here, I think if I just copy paste, it's going to create not exactly what I want, but yeah. But I don't want them to be linked, I think. But we won't move that far. Okay. So I think this is fine because now this exists at the end of the timeline, which is exactly where I want it. Because if I was going to go back and edit the original base holder, I would have to do it at the point in the timeline that I built the base holder, so I wouldn't have any of this other geometry to work with, which is not at all what I want. let's see. I wonder if I want to make this PCB longer so that I can put my mounting holes over here and then maybe some kind of vertical standoff. Let's go ahead and do that. So instead, we'll come back here to our moving light shield PCB, which I have yet to design and build, but we'll assume that it's really, really good. Do that. And in this sketch, instead of just capturing this little area, I'm also going to project this upper PCB. And then when I do the extrude, I will include that area as well. So now that PCB is going to be just as long as the network PCB above it. So we'll save that. We'll come back over here. We will get latest. Yeah, very good. And actually, why don't we go ahead and make some decisions about mounting holes now, because that's going to influence a fair amount of this design. My impulse is to go because a lot of the force on this is going to be coming from this side, where we're going to have a DC jack on the bottom and a network jack up on top. I'm going to need a pretty good amount of connection here and then something down on this end. So let's go ahead and rough those in now. So bottom, we'll do this as a new sketch in here. Let's say, now again, all the geometry for this box is going to be based on these holes, so it's not like I can't change my mind later with some pretty good ease, but I would like to get this at least close to start with. And then let's mirror this over center line. This, mirror line. Great. Stop sketch, and then we will do an extrude to object. The object will be the top of the PCB, and it should automatically do a cut. Yeah, all right, so those will be my mounting holes for now. I think that's not a bad place for them. I mean, honestly, except this side's going to need to have the DC jack in it, which without knowing more about what that jack is, I mean, this would be a really optimum situation for going back and forth between Fusion and Eagle, except I don't think you can push changes back and forth that way. I think you have to basically you make something in Eagle and you're continuously importing it, or you are building something in Fusion and continually exporting it. I don't think you can really go back and forth with your design changes the way that I kind of want to here, which is a shame. But let's see. So probably what I want to do is actually do 2 mounting holes on this side. So let me decoincide that. We'll do a vertical line somewhere here. We'll move this center point to coincide with this guy, and then we will mirror this across the center line. Stop sketch, and then we'll need to redo our cut so it includes this new circle. All right. Oh, except I don't want this to be here anymore as well, because that obviously moved with the other one because it's just mirrored across the center. So let's break that mirror relationship, and we'll just shift this up here. Stop sketch. Okay, so that'll be my mounting solution for now, and we can always come back and change it as I build that PCB. All right, let's save one more time. I'll come over here. We will get latest, which will include my mounting holes. Okay, so let's see here. So this is the sketch where I defined my base holder. Oop, come back. Where'd you go? Oh no, I'm editing the geometry way back where I defined. Oh, it is a copy. It's a shame. So what's happened here is when I made a copy of this component, it is literally a duplicate. So they share the same timeline, they share the same sketch definitions. So when I edited it there, it took me back to the very beginning of the timeline, because this is one of the first components that I created back when I was making this project, which is not really what I want. I want a version of all of these bodies that exist later in the timeline. And I'm pretty sure there is a way to do that, but I'm not sure what it is. Right, because all of this should exist right at the end. Yeah, So copy paste base holder 2. So let's delete that feature. So my original base holder is still here. Yeah, okay. So what I really would like to do is duplicate these bodies. Let's see, can I selection priority, selection body? That component, press pull, move copy. What I want is, can I create a copy in place? No. Can't create a copy in the exact same physical location, which is a shame. Well, I mean, I could just modify this base holder with some extrudes. For now, that is probably the way I will go. Yeah, we'll just go ahead and get on with the thing. Sir, we will create sketch. We'll come on this. Oh, actually, hang on. No, stop sketch. What component am I? I'm my global component. Aha, okay, so this we talked about last time as well. As you always want to be doing these things inside of a component, because you can't change your mind later and put them in a different component. So I'm going to make a new rectangle, which is going to represent the new dimensions of the base of this unit. So this side obviously doesn't need to be any bigger than it used to be. Oh, except I still have my selection priority. There we go. So those selection priority filters are actually kind of cool. You can, let's project this in, project. You can use them to sort of tell Fusion what you're going to be, what you want to be selecting, whether it's a face or an edge or a body or what have you. Why can I not coincide these two things? I would like this to be coincident with that, please. Selection filter, selection priority, selection tools, select, coincide. I can sort of tie with that point. I guess that's the same thing. Well, that'll be fine. All right, let us define. Oh, here, let's project in this guy as well. Boop, boop. Get that edge in there, and we will define how far outside the edge of the PCB this base extends, because it's going to want to fit a cover on top of it, I think. So let's go like 3 millimeters. And then I think on this side, this is going to want to be, I want this Ethernet surface to be proud of my case, but only just, I think. So let's make that like 0.5. Oh, nope. That 0.5 millimeters. All right, and then on this side, I actually need this to clear that USB. So I'm just going to bring this up here. And then, oops, this is going to be, let's say 1 millimeter. It's going to need a base on top of it too. Let's make this 2.5 millimeters. Okay. All right, so stop sketch. And then I'm going to make this the same height as my other base here. So I'm going to create a plane, which is offset 0 from that. And then I'm going to extrude. I'm going to extrude this base and the area under this PCB and what will ultimately be our standoffs upward to, oops, no, not distance, to object, to that plane we just created. And it's going to join. Doesn't like that. Doesn't like that one bit. I wonder why not. All right, let's try again. So my profiles are going to be this base, that area, this, this, and this. Okay, and it's going to object. The object in question is distance 2. It's going to join. Will you let me? Yeah, all right, it's good. So those things seem to have merged together nicely. Alright. Oops, saving recovery version. Alright, and let's turn off our line there. Alright, so that's going to be the new base of this thing. And actually, now that I'm looking at it, I could make this a whole lot prettier. Like, I don't need some of this extra area. Although that might be useful later for a mounting solution, so I think let's leave that for now. And we'll start thinking about how in the heck the cover's going to go on this thing. I mean, I think it can just slot... It could just slot over the top except for this Ethernet here. So what if this printed base was more like a cup and had walls coming up around it, and then there was just a lid that went on top? Because then I could get in under this Ethernet shield with that connection point, which I think is what I want. I also didn't account for, like, this is now flush to this PCB here, which I think, how thick is this? 2.8 millimeters, that's not, that is a little bit tight. Like, I could do a threaded insert, but that's a little bit, that's quite a bit of extra work. I could do a standoff, but that only makes it taller. What are we gonna do? What are we gonna do about that? I mean, I could do a threaded insert underneath these. I would probably have to make this base quite a bit bigger. Because we said the other day, let's open up that previous model and we can see if those, what the height that we needed for those standoffs was. So we will open, go back to recent data in Fusion here. In recent data we've got, we'll do QRP amp. Yeah, okay. So we said the hole size to fit a standoff in was 3.4 millimeters in diameter, and this was, let's see, I need a vertical height. I guess I can inspect these two planes, that plane and that plane. 3.1 millimeters. So if so 3.1 millimeters. So that's actually not too bad. So I could add an extra 0.3 millimeters, which is basically an extra print layer on the printer, and be able to do a threaded insert, and then a little extra for like 2 top layers. That's not the worst. Why don't we plan on that? Because I think keeping this thing slim is going to really be to our advantage. So let us, here, we'll extrude this. Here, you know what, let's do this the way we mean. So really, I want this thing to be 3.1 millimeters plus a little bit more. So I will do 3.1 millimeters minus 0.6 millimeters. Oops, minus 0.6. Okay, so that'll be our plane, and then we're just going to extrude the bottom of this down to meet that plane. We'll just thicken that body up a little bit, and we'll turn that plane back off. Cool. So let's see. All right, I guess I can take care of those mounting holes now. So we'll do a new sketch on this layer. We will project the holes in our future PCB. And then I will turn that component off so we can see what we're doing. All right, and then I'm going to need a circle, which is 3.1 millimeters. Centered on each of those placement holes, 3.1 and 3.1. Great, and then I can stop sketch and I can extrude those. Oh, no, those should all have been, what should all those have been? I just looked at this. Let's open that QRP amp. So this is the nice thing about Fusion is you can always just go back and look at your you can look at your previous designs and like reuse some of the data that you gathered the first time without having to go and like figure it out again. So 3.4 millimeters in diameter and 3.1 millimeters in depth is what I'm looking for. Okay, so I'll get it right this time. So, and really what I should have done is make these all reference a single dimension so that I didn't have to change this in multiple places. I'm really just not holding that together so well tonight. All right, so those are all good. Okay, so we'll stop sketch, and then we'll do an extrude of these various faces. And we'll do minus 3.1, those cuts, and cuts down in. Okay, so that'll be the placement of our threaded inserts into that base. So let's turn this back on. Okay, so that would now be firmly mounted there. So now it's just sort of a matter of building up the cover that we want to fit over all of this. And I guess it couldn't hurt to think about how is this cover going to be fastened in place. The other thing I'm sort of thinking about now is when I had imagined building this base PCB, I had imagined sort of the connections coming in from the bottom side. But the way that I've constructed this now, that's actually not possible. Which is going to be exciting. So like, how do I, I have three 3-pin header connections to make to this PCB. And because I've used this PCB as a mounting plate now, that's not really possible. Okay, so I think what that means is I actually need to go back to the initial plan, which was to have this whole assembly lying on its side, so that I can get the servo connections and the LED connection down to that PCB when I need to. Well, that's a bit of a bummer, but I think it's going to be worth it. Is there any way? I mean, I could have those cables like snaking in here somehow, and really, like, there isn't any. There's no reason for the network PCB to actually connect to this thing. I guess they will be sharing a power bus, but none of the signal. Oh, I guess the signal buses will be coming here too. Yeah, I think we're gonna punt. I think we're gonna go back and so these mounting holes that I just made are no longer necessary. Let's see, base holder. Yeah, all right. So I'm gonna actually undo because the whole size of this thing is gonna change. So I'm gonna undo a bunch of that work I just did, and we'll do this thing again. So come back out here. We'll find near the end of the timeline here somewhere. Yeah, where I captured position. Great. So I'm gonna go back to my initial plan, which is that this guy really wants to lie on his side, much like that. Yeah, because this way I can use the bottom side of this PCB to make my electrical connections, and can I still use it as a mounting point? Is this going to be super weird? These are all valid questions. So I think with the appropriate amount of, like I said, if I want to get this really close, I mean, I think I can get like 3-pin header connections over here. And probably, actually, what I should do, let me scoot this whole thing over, because I'm thinking about how I would use this in a lighting sense. Like when this head swings down, I don't want to hit the body of my things. I'd rather have a big sort of butt hanging off the end, which means I would make my electrical connections over here, which is good because, well, it's fine. So like the way the servo is currently arranged, I have, and this is actually, I guess, sort of a flaw in the way I've assembled this thing, which maybe I should rectify now. I have wires coming off of this end of the body, but the other side of the servo that does the pan, and it would be really great if those were the same side. Let me look at something really quick off camera. Yeah, cool. So let's see here. Yeah, so probably what I should do before I actually get into this is actually do, like, reassemble this so that this is pointing the opposite direction. Or I can just assume that Jeff Glass, when he builds these things, is going to assemble these in the opposite direction and figure out how to illustrate that in Fusion later. Maybe that's the way to go. So in that case, the light is going to be pointing towards screen right, which means that this is actually going to be upside down. Something more like this. Yeah, I think this is the way to go. Because now, yeah, this will be great. Now, this light can shoot past the front of it here. I can make my, this servo connection can be made right here. This body connection can be made in here. The LED connection can go right in. And then I have Ethernet and power coming off the back. So then it'll be up to me to figure out how I want to handle, like, these mounting holes, like, but this actually probably always makes it simpler because I can just do a flange and do like a bolt and nut. I can do a threaded insert. I can do sort of whatever I want to do with these. And then in terms of overall profile, like, I'm not super thrilled with how chunky this will make the light, but it's still pretty adorable. I mean, the sort of goal for all of this is adorable, right? So let's go back into here. Let's our total overall footprint. So from here to, say, here, 64 millimeters. So that's, what, just under 3 inches? Ah, that's adorable enough. That's adorable enough for me. I can live with that. Okay, so now we will go back into our base holder and redo some of that work we had started on, thinking about how we're going to assemble this thing. So I think in this construct, what I will do is this base holder, I will make a big plate with more flanges that we can mount this to, and then that can just bolt in as, this can all sort of bolt in as a unit to whatever those flanges are, which means, and then the cover can actually just come down over the top, and then I'm going to have like a spare, I guess I'm going to have a little nubbin down here to fill in the bottom of this Ethernet, and then we can fill it in from the top. I think this is actually going to be fine. Like, it doesn't increase the overall size of this moving light all that much. Okay, so let's do this all over again. So we'll make a sketch on, oops, not extrude, we'll do a sketch on the bottom of this face. Yeah, cool. So we'll do a rectangle, something like that. Like before, I was going to project this in, and this line can be coincided to that point because this doesn't actually have to be any bigger. This line can be coincided to that point because is that true? I guess this would need to move a little further forward so that I can put a shell on top of this. So let's actually just go back and do that before we get too far here. This is one tool that I would love to see Autodesk improve a little bit, is your options for more specifically moving and placing inserted components or assemblies from other models. Like, I would love the ability to like snap this down to a plane, which is just something that you don't have yet. You get point-to-point moves, but you don't get like move to plane or align or something like that. Let's see, assuming the USB can be a little bit proud, I think that will be fine. Okay, so we'll capture that, and we'll come back to our base holder sketch. Okay, so now we've got our big rectangle. Those are flush. This, let's project in. We're going to need to enter our sketch, of course. Sketch, enter sketch, edit sketch. Yeah, there we go. I'm going to project in this guy, and then I want to create some clearance here. So we'll clearance that by, oops, over constrain. What? I don't think so. Oh, I accidentally created a new sketch. What I wanted to do was edit the previous sketch we'd started. So we'll take this USB here, we'll dimension that off of that guy by 4 millimeters. By how thick do the walls of this thing need to be? Well, let's see what the walls of the previous base cover are, because I thought those were quite good. These guys, if I inspect that line, those walls were, these walls were that line and that line. 2.4 millimeters. I think that's a pretty healthy size for a cover for this thing. So these is going to be 2.4 millimeters plus 0.8 plus a millimeter of clearance. Should be plenty. And then up here, let's say I want to clear that by the same 2.4 plus 1. Stop sketch. Okay, and come back and round these corners off later. So now we'll make a plane that is the same place as our top one. We will extrude this bottom layer and everything on it. To meet up with that plane that we just projected. And we will do a join. Okay, so now my base is real big. And should encompass all of the things I need it to, which is kind of cool. I guess you could come back in and round those corners off now. Maybe I'll do that just to make sure we're not going to run into problems later. So on the bottom here, so when I originally did this, I had this radiused corner, which I quite like. Let's see if it'll tell me. Radius 3 millimeters. Great. And then stop sketch. Oh no, I'm sorry. All right, I want to edit that sketch. I'll make a circle with radius 3, and then I will make it tangent to that side and that side, and then I will do the same down here. So I'll do a circle with radius. I'm just gonna hard code these because it's a little late in the evening and I'm feeling a little lazy. Tangent to that side, tangent to that side, and then one more time. Except that's a diameter. I want a radius, so I'm going to do 3 times 2. There we go. And we'll do 3 times 2. Great. And then one more time up here, 3 times 2. And I will tangent this side and that side. And stop sketch. And then I'm going to go back into my extrude, and I'm going to deselect these corners. Let me cut them out of that. Okay. All right, so there's my new base plate, which is not as chunky as I was worried this thing was going to be, so that's quite nice. So next, I'm going to build the flanges that are going to accept the bolts that are going to run through this PCB. So first, I'm going to turn off some of the upper parts of this. The yoke I don't need. I think that's everything. Oh, and the servo. Yeah. Okay, so now I'm going to do a sketch on this layer. And I think just like a vertical pillar, and then we'll do some like chamfering on the bottom should be fine. So And actually, let me project in my holes, which will be quite classy. Come back to the top here. Yeah, cool. So now I can run a construction line between the two of them, get a center line of my hole, and then I can center my column, my pillar. Let's call it a pillar. I can center my pillar on that hole, and we will dimension this guy. Let's make that like 2.5 millimeters. And then assuming, yeah, so that's a solid surface. Okay, so actually, so let's do these two pillars in two separate sketches because they really are different ideas. So I guess I'm going to try to run this all the way to the top of the PCB. So I'm going to make an offset plane parallel with the top of that, and then I'm going to extrude this rectangle to that plane. Great. And then I'm going to fillet, not chamfer, but fillet. Oop. It's a bit much. Just to give that a little additional structural strength. So make sure that fillet didn't come up. Yeah, so that fillet is actually going up through where the hole will be. So when I punch I think that'll be fine. I could get fancy and like try and flatten that out, but it's just going to be bolted through at the end of the day. Well, I can always come back and do that later. Let's do a little top fillet here as well for class. All right, so and we'll come back and punch the holes in one operation, I think. So let's turn off the planes that we've been working with. We'll do an additional sketch on this bottom layer, and once again we'll project in our hole and the geometry we're working with. All right, go back to the top. We will make a construction line to find the center of that hole, and we will once again make a line here and then mirror it across that line. I'm also going to, what I can do is just make a construction line from this original one, make that construction. Oop, I think it's going to back me up here, which is not bad because I haven't saved in a while. There we go. Let's save. All right, I'll make that construction. We'll make this coincident with that, so we make sure that they're always the same. Oops. Oh, let's hold this to vertical. There we go. Now, when I make this coincident, that's what I want to do. All right, and then these two link up, so this should be a solid surface. Yeah, great. And then I can reuse that top plane. Come on. I can reuse that top plane to do this extrude to object that plane. Great. And actually, looking at this now, you know what I should do is just join up these two sections. So let's do that. So we'll link let's see, link this section over to here. We will make that horizontal, make it not a construction line, and same thing down at the bottom here. It's interesting the way that it makes assumptions. Like when I dragged it sideways like that, it assumed I meant a horizontal line until it thought I was a coincident line, and then it assumed I didn't want to do both of those things, which unfortunately is exactly what I wanted to do. So suck it, Fusion. All right, and now actually here, let's chamfer this edge down a little bit for class. No? Yeah. This is like very hacky. Like what I should be. You know what? Let's do it the right way. Which would be to make a sketch here and go from that point at a 45-degree angle and coincide it. Stop sketch. Extrude this guy to the other side as a cut. Yeah. Okay. Oh, except I need to get into the backside here with a bolt. Well, beans. I guess I can undo that and leave a little hole in there. I could put a little holder for a nut in there. Wouldn't that be classy? Yeah, that would be super classy. Yeah. Okay, let's do that. Okay, first let's punch our holes through. So how do I want to do this? Let's, in this object, we'll make a sketch on this plane. I'm going to hide this object. I'm going to project my geometry onto my sketch. I'm going to show my object again. I'm going to hide the bodies on it. I'm going to stop sketch. Okay, and now I'm going to take those 3 circles that I just projected, turn my bodies back on, and I'm going to extrude them to this point and cut through those, and those will be the holes for my bolt. Didn't want to let me do didn't want to let me extrude through a different body with an extrude through, which is, I don't know, I feel like I've done that before, but that's all right. All right, cut through that, and then we'll just do this as a second operation. So once again, turn that body off. We'll do, we'll need our sketch back because it's automatically turned our sketch visibility off. We'll do that, we'll turn our bodies back on. We'll do 2 objects and we'll extrude through that. Okay. Ooh, it's a little bit narrow. Why don't we go back into our sketch here? Not that sketch though. Into this sketch here. And just give ourselves some more room to work with. Stop sketch. Okay, so there's that. Alrighty, so now, so these 2 connections can be made with just a nut on the backside, but this one is gonna need some love. So I think the classy thing to do here is to do like a nut, like a captive nut insertion from the top or from the side, which I think that's a really classy idea. So let's make sure we're at the very end of our timeline, and we are. Let's save again. And we'll go back to our old friend, the McMaster car catalog. All right, one quick take a peekaroo. Insert McMaster component. We will take a nut. It will be a hex nut. It will be a hex nut. It will be a 3mm. An M3. Yes, here we go. Now, can I resize you? Yes, thank goodness. Class 8, medium strength, low strength. They're all going to be, I think, dimensionally exactly the same. Yeah, it'll be fine. So we'll take that and we'll download this as a step. Yeah, there we go. Okay, so now let's come and position this where we want it. So I'm going to rotate this by 90 degrees. And I'm going to slide this up into place. Let's go to the top view and see if we can't tell what we're doing here. Do I get a center point on this? I don't know that I guess I do. Let's turn base holder off, and then maybe I can align it with. It's like, you know, I wish I could like tell this to be concentric. I mean, what I maybe should do is use a joint, right? And like join this in a concentric fashion to this hole. Maybe that's the way to go. What's gonna be any good at all? I think that's concentric. It's so hard to tell with these screw threads. I don't have like a center point side. I guess I could add a sketch to this and make that point, but I think this is going to be fine. If I come at it from the back, oh here, now if I go in here, yeah, so I can close off those. That's going to be plenty fine. So I guess it's not technically exactly centered, but like close enough for government work. All right, so go back into our base holder. Ooh, yeah. Oh, right. So I actually want this to be not intersecting that surface. So we'll capture that position. And now we're kind of inside this other surface. But I think that's okay because let's do a combine. I'll do this at the global level. So I'm going to take this as my target body. My tool body will be the nut. And I'm going to use that to cut the other body. Oops. But I want to keep tools, so I don't delete that after it's gone. All right, so now they're not technically intersecting. And now I'm going to create a sketch on this face, and I'm going to project this nut onto it. I'm going to hide that nut. I'm going to, because what I want to do is basically cut out this little like nub in here so I can actually get the screw in there. Ooh, and I also would like to remove those screw threads. So, so I guess what I want is a plane at angle, right? I want a plane that passes through that bottom point at 90 degrees. Construction visible. There we go. At 0 degrees. There we go. All right. And then I want to take those two, extrude them to that point, and cut through. Oops. I want to cut. Yeah, I want to cut this base holder. I guess I'll do two sides. One will go that way and the other will go 1 millimeter out. Oh, now why is that cut starting on that side? What plane is this on? All right, I'm gonna cut to that plane. Like, it doesn't look like it's actually cutting anything, which is super weird. Let's try this again. Let's delete this sketch. All right, let's go into our appropriate component, because I'm being bad at doing this in a global component. This will be in our base holder. I will do a sketch on this face. And now I will project that and that onto this face, and then I'm going to construct lines which basically come from here as low as they might need to go. And is this contiguous? Yes. Okay, great. And then I'll do the same thing on the top. So this is going to make sure that I can slide my nut into this assembly. And then I'm going to do that same plane at angle. So I guess I didn't really need to delete that. Ooh, come back. 0 degrees. And then I'm going to extrude these various forms. Cut. All right, that's what I wanted to do. Great. Oh, that went so much better. I don't know why that went so much better. That's exactly what I thought I was doing the first time. But whatever. Let's also take care of this shenanigans. This happened early in the project too when I was doing moving light work, and it's just when you cut away a screw thread, it leaves this big old thing that you don't, you take a threaded part and you use that to Boolean cut another part. So make sure, so like now I'm kind of getting trapped behind all these other things. Which I don't love. And something is coincident there that's not supposed to be. So let's try this again. So here, let's start the circle somewhere. All right, stop sketch, and then we will extrude all this geometry to that surface, and we will cut. All right, well then I will do an offset plane on that surface, and then I will hide it for a moment, and I will again take all that geometry and extrude it to that plane as a cut, and we should clean up all of that. Yeah, cool. All right, so there's our sort of captive nut positioning, which is kind of cool. We'll save one more time. How long have we been going this evening? An hour 50? That's probably about as far as I can go tonight. A little bit low energy tonight, not a whole lot of visitors. That's totally fine. This was super fun. So like, here's what we did tonight. We roughed up this Arduino Pro Mini model. We sort of established some parameters for this PCB that we'll have to design. We enlarged our base holder and built some sort of vertical mounting posts for it. And then on this vertical mounting post, we created a place for a captive nut to go in this side. Ooh, you know what? Let's do the final touch. Let us. Can I just extrude this face? Oh, I sure can. Yes. So those we're gonna extrude and join. Yeah, cool. So now that nut should slot right in there, plus or minus tolerancing, but I think we'll be okay. Neat. Oh, that's classy. That's gonna be super fun. So let's turn the rest of our unit back on, and we can sort of admire how far we've come this evening. Excellent. Yeah, so that's coming along. So we'll, obviously, I think the next step is going to be finishing out this cover. Probably here. You know what? Let's. Yeah, I mean, ultimately, I think what I would want to do is like put some. Once this is prototype, well, I would do some sort of rigid stop in here just to give this a little bit more. Because otherwise, this is just sort of resting here and attached only by this. And like I could put because this is all sliding in from screen left, I could attach this here, and then I could put a stopper to support the bottom of this PCB. And let's see over here by the I could do. I guess I can't really do a vertical stopper here. But that's all right. That shouldn't be. I could do one actually that's in here. Can I? No, because everything's going toward the top of the screen. So I guess I can't really do that without impeding the motion of the thing. But that's all right. Just even something in here just to help stabilize a little bit wouldn't hurt at all. But yeah, that's the gist of it. So next time we'll work on the cover. That will cover up all of this and this guy. And then we've left ourselves, I guess, as far as mounting solutions, I haven't really gotten that far. Maybe something that bolts through in this corner or something, some kind of plate. I don't know. Running out of steam a little bit tonight. Gonna call it a night. Thank you so much for joining me, and I will see you next time.